So today in the subject electronic circuits, we would be learn about the topic buck regulator or step down converter, you can say. So in the last lecture, we have discussed about SMPS. So this is the one of the type of regulated power supply. Here you can see that whatever the output voltage would be obtained, that would be less in amplitude as compared to the input voltage. That's why it is called as a step down converter also. The another name is buck regulator. So here we are discussing about the DC power supply only. So your input would be either it is coming from the DC supply, or maybe it is a rectified DC that is generated through the rectifier and filters that we have already discussed in the last lecture. And output would be also a DC voltage, but it is decreased or less in the amplitude as compared to the input voltage. So this is the basic circuitry of this step down converter. You can see in this arrangement we have used a BJT as a switching device. So the collector of BJT is connected to the positive terminal of the input voltage. Emitter is connected to the output end where it is connected to the diode and inductor. And in the base we have to give the connect the control circuit of the SMPS. Okay, and it is pulse width modulation with form would be given as a switching input. And there is a diode. It is connected in such a way that its cathode would be connected to the emitter terminal of this transistor or switching device. So it is, you can say, at the first end when your transistor would be turned on, it would be positively charged the cathode end, and it will be negative, means it is reverse bias. And if it is reverse bias, there is no current would be flow, and whole current would be flow through the inductor through the load. This is the loop where the current would be flow. But in the second case, when your switch would be off, this would be become forward bias. So we would be see how it happens through its operation. Okay, so that is all about that we have already told you. Now see the circuit operation. If you would be see the circuit operation for the circuitry, you can find out that in this particular, this is the arrangement shown when your transistor or switching device Q1 is on. You can use either BJT or MOSFET. It does not differ any operation of the circuitry. Okay, both are acting as a switching device. But if you are using a BJT like this we have shown in the circuitry, it would be operate in the saturation region to act as a switching device. So now in the first case, when the Q1 is on, means this transistor would be biased in the saturation region. It would be acting as a closed switch, and this is the input DC voltage. So when the Q1 is on, you can see the voltage at across this terminal of the switch would be now VI minus Vsat, because when the transistor would be still on, in the practical cases there is some amount of voltage drop across it, that is shown here as a Vsat. Now the one current would be start to flow through this particular network, and as the positive terminal is connected to the cathode of the diode and negative is at the anode side, so this device or diode would be in the reverse bias condition, and as it is in the reverse bias condition, it would be act as an open circuit. And when it is act as open circuit, no current would be flow across it. It would be zero. The current flow through the diode is zero, means no voltage drop across the diode. the whole current would be start to flow through the input towards the inductor. Now you can see IL is nothing but equal to the I here, and that current would be start to flow across the inductor. You can see the polarity of the inductor, the positive at the left hand and the negative at the right hand. Because of this current flow, the current would be linearly start to increase the or start to charge the inductor. Because of that, you can say current is linearly increasing, and because of that, there is a voltage difference would be created across the inductor, and that VL is nothing but VI minus VSAT minus V0. How this value would be came? You can simply apply. You can follow the loop. Loop is start from the input terminal, goes through the inductor, and then through the load, it would be come back to the input side. So because of that, you can apply the KVL. When you apply the KVL, so VI minus VSAT minus this voltage is VL minus the voltage across the load is or capacitor is, because both are in the parallel, so voltage across both of the component is V0. It is equal to 0. So VL is equal to what? VI minus VSAT minus V0. So in this way, you can see the voltage across the voltage drop across the inductor is a positive quantity, and it is VI. It is less than the input voltage, because apart from VI, you can see the rest of the term is deducted from the input voltage. So means VL is less than VI. Okay. Now the current would be also follow this loop, and it would be flow across the load. So the current that is flowing across the load is I0. Okay. So in this way, you can calculate the voltage drop across inductor, as well as you can calculate the output voltage also when the Q1 is on. So what is the value of output voltage here? Follow the same equation. So V0 would be VI minus VSAT minus VL. Okay. Again, you can see output voltage is less than the input voltage by the amount of VSAT plus VL. So in this way, we can say that it is a step down converter, because here your output voltage would be decreased in the amplitude. Okay. So this is the operation when Q1 is on. Now we have to see what happens when Q1 is off or switching device is off. So when Q1 is off, you can see here it would be act as open circuit, and as it is an open circuit, there is no current would be flow across this. Okay. So what happens? So how the circuit would be conducted? We know that inductor and capacitor both are charge storing device. So here you can see inductor would be store the charge. Okay. And as the inductor would be having the capability of storing the charge, then what happens? Whatever the charge is stored at the inductor, that would be start to flow across the loop. So now you can say that this is not in the picture. This would be out of the picture, because this is open switch. So the no current would be conducted across it. And now because of you can see here that as the Q1 is switched off and inductor has stored the charges, so it would be oppose the any change in the current level across the inductor. Already we know that the current has linearly increased in the previous case, and it would be attained some level. So it would be, it remains at the same level, and inductor would be not easily uh, ready to change its current level. So what happens, in order to maintain the inductor current flow, inductor would be reverses its polarity. You can see here, here inductor's polarity has been be reversed. Okay. Now because of the polarity has been be reversed across the inductor, this diode polarity would be changed. Now cathode would be become negative and anode would be become positive, and it would be suitable to the diode to be become a forward bias. So now diode would be in forward bias condition, and when the diode would be in the forward bias condition, this current across the inductor would be achieve a path and would be start to flow across this diode. So now the loop or the circuitry that would be used here to flow up the current is, see, lots of the students only join the session for attendance and they are joining very late. So I have locked the meeting room, and from the next lecture also I will be do the same. So I am admitting today, but from the next lecture it would be not happen. Those who would be not joined up to the 10 minute of the lecture, they would be not further entered. Okay. Now see here, as I have told you that current would be get a path because the diode has will be forward biased. So current would be flow in like this. So when the diode would be forward biased, a current that is flowing across the diode is IL, that is nothing but an inductor current. So in this way your current would be flow across the diode. Now in the previous case, as the inductor is charged as well as the capacitor was also charged, as we are keeping the value of capacitor very large, so that it would be take the time to charge the capacitor and the voltage across the load would be maintained at the constant value. Now at this condition, these devices would be start to discharge because there is no incoming or input current or voltage is there. So it would be start to discharge through this particular loop that I have shown through the red pen. Now you can see as the polarity has been reversed. So what is the voltage drop across now inductor? You would be see that the voltage across diode is what? Suppose it is Vs plus 2 minus the drop in the voltage, it would be considered positive. Then again rise in the potential across the inductor, you can be take it as a negative. Now again the drop in the potential across the load, you will be take again it is a positive. So it would become 0. So VL is equal to what? V naught plus VL. The voltage across the load and diode, that would be sum. After summation you would find out this is equivalent to the inductor voltage. Okay, the drop of the voltage across the inductor, or you can say the discharging voltage. Now you can see that what happens if for this circuitry if diode D1 would be not present. Imagine the condition when the diode is not present in the circuitry, then what happens? Can anyone answer me? What would be happen if diode was not present in the circuitry? Sanket Bhor, can you answer this? If Sanket Bhor is present, Sandeep, one way. No response is coming. So I would be consider you both are absent. You have just turned on your mobile phone and connected to the lecture, but you are not present by your mind. Whatever the understanding regarding the circuitry, you have to just answer. Either it is wrong or right, it doesn't matter. Dongre Nikita, have you any imagination that what happens if the diode D1 is not present on the moment when Q1 is off? Then what happens with this circuitry? See, if diode is not present, then what happens? The voltage across the inductor become large enough, means it would be still increasing and increasing, and would be become large enough so that it would be break the transistor or switching device. It would be damage the circuitry because there is a no component in that particular circuitry except diode that would be catch this inductor current, that would be handle this inductor current. So this is the benefit of connecting the diode in this circuitry, so that what happens, whatever the rise in the inductor voltage, that would be catched by the diode D1. That's why its another name is also that catch diode. Its another name is catch diode here. So the catch diode would be catches the voltage across the inductor VL and stop it from increasing. Okay. So this is the operation of buck regulator in the two modes when the Q1 is off and Q1 is on. Now we have to be see the voltage diagram waveforms. So everyone draw this diagram or take the screenshot, whatever convenient for you. You can see here there is a some voltage are shown. VA is what? It is a switch voltage. The voltage across switch means transistor. Then VL is the voltage across inductor. IL is the current across inductor, and this is the output voltage. So we know that switch having at the base terminal, it would be having in the base terminal, it would be having the switching voltage, okay, that is coming from the PWM output. So it would be having the T on time and T off time. It would be a time varying pulse. So when your switch is on, this is the condition. This is T on when your switch is on, and this is T off when the switch is off. So when the T switch is on, you can see that your inductor voltage would be Vi minus V sat minus V naught, that is positive. It is positive. Okay. And this is the reference level, ground level, you can say. And at that moment, the current across the inductor would be linearly increasing. And when the current would be reach above the I naught is the current across the load. So then what happens? Your capacitor would be start to charging. So your IL would be distributed into two parts. One is current across the capacitor, another the current across the load. So in this way, what happens? Before that, IL is equal to the I naught, but after that, IL would become larger than the I naught, and at that moment, what happens? Your output voltage would be little bit start to increase from this level, base level. So actually, output voltage would be it is shown here. There is a variation in output voltage, but it is a very micro level observation. Generally, if you would be see, this is would be remains constant. But if you would be micro level, there is some variation in the output voltage, and that is very small. This is called the VR, ripple present at the output voltage, and it is very small in some millivolts. Okay, so you can neglect also it and consider the output voltage is remaining constant. But we have already learned for the switching regulators, output voltage is also a rippled output. It would be not perfectly constant like the linear regulators. Okay, now the second condition, when the Q is off, at that moment what happens, your inductor voltage would be across this inductor voltage there is a negative, and it would be V0 plus Vf, that is shown here. And at that moment your inductor current would be start to decrease across the diode. It would be start to decrease across the diode. Okay, and till it would be not reach to the I0, your output voltage is keep increasing within their small range. But when it would be decreased below the I0, it would be start to decrease again to the baseline. So in this way, you can see the waveform of the step down converter would be work, and you can easily plot it if you have the clear the concept of the working phenomena of the step down converter or the buck regulator. You can easily draw this waveform. And in the examination, circuit operation and waveform, all three are important. Okay, so this is generally asked in the description, descriptive questions of 6 marks or 8 marks maybe. So you have to be ready with this description. Now we would be come to the I would be just show you one of the video regarding this buck converter, that whatever I have explained, it is similar video that you can see here. That would be give you the explanation how this buck converter works. Okay, so you can see here the first condition, when your diode is reverse bias and switch is on, so at that moment the current would be flow through this path as well as through the capacitor. Okay, but when your switch is off, so diode would be turned on and the current would be flow only these two paths. Okay, so this is the way that they have to be shown you to the flow of the current as well as the polarity of the current and voltages. Okay, so inductor current grows, collapse, that all operation they have been shown here. What happens when, and this would be shown in the continuous manner, because at the input of the switch there is a time varying pulses are there, so it would be continuously on off like this. Okay, now I hope that the operation would be clear to in your mind. Now we would be see back to our presentation, and now the second kind of the converter, that is called the boost regulator. So this is the also the another name of this is step up regulators. Okay, so you can see here the arrangement of this particular circuitry is little bit changed as compared to the buck regulator. Now you can see here in this particular circuitry, the inductor is came or bring up to the near to the input terminal. So you can see here, this is the regulator that is basically used to step up the value of output voltage or to boost the output voltage with respect to the VI or input voltage. So here V naught is greater than Vi. In the previous case, it is less than. So for this purpose, we have rearranged this component, and inductor has been be directly connected to the input supply, and switch or this BJT transistor would be here, that is connected across the input voltage source. So you can see collector is connected to the one of the end of the inductor, and the emitter is connected to the ground. And at the base, we would be apply the PWM input, pulse width modulation input, that would be coming from the control circuit. Okay. Now the diode is connected in series with the inductor. Okay. So the voltage at output of the switch is nothing but this is a VA, that's why I have indicated here A, and diode D1 and L1 both are in the series, so it will be shown here. And now capacitor is, again capacitor would be connected across the load as it is in the previous case, and this is the arrangement of the R1 and R2 that we have know that this is the basic taken from the basic block diagram of this or circuit diagram of the SMPS that we have discussed. So the value of R1 and R2 would be also a deciding factor because it is providing a feedback path to the switch. Okay. Now we can start to learn the operation of this push regulator. Again, there is a two mode of operation. First, when your switch is on, that is transistor Q1 is on. So you can see here whatever I have told you, that is mentioned in this particular slide actually. Now the first condition, we have to come to directly the condition, mode 1 condition, when your Q1 is on. Now see what happens and how the operation would be followed. Now you can see here the input voltage Vi. When the transistor is switched on, then what happens? The current would be flow across the inductor as the diode is in series with the inductor, and voltage, your switch is on, there is some voltage would be developed across this transistor switch, and it would be developed in such a way that this negative polarity would be appeared across the anode of the diode and positive polarity across the cathode. So again you can see that diode would be become reverse bias. When the transistor Q1 is on, diode would become reverse bias, and as the diode is reverse bias, it would be act as a open circuit. Okay. So there is no current would be flow across this diode. So also there is no current would be flow across this capacitor and the load also. So the current would be only flow on this particular part. So in this condition, what is the voltage across the inductor? So the voltage across the inductor would be, you can directly apply the KVL.
Hello.
Yes.
Hello, sir.
Yeah.
If switch is off, then current is not flowing, na?
Which switch?
Q1.
Which particular circuit you are talking about?
Sir, it IN.
You are talking about this circuitry or buck regulator?
This circuit.
Oh, okay. I am not coming to that condition. I would be come to that condition. This is the first condition when your switch is on. Okay. So after that, I would be explain that particular condition. Then you can ask. Okay. So in this condition, what happens? Your switch is on. So at that moment, current would be flow across this path. So the voltage across the inductor would be, what happens? Vi minus VL, and the voltage drop across this switch is, suppose it is Vsat, because the polarity is different, so you have to be like this, equal to 0. So VL is equal to what? Sorry, it would be plus minus. So it would be VL is equal to VI minus V sat. So voltage across inductor would be now VI minus V sat. Okay, this is the condition when your transistor is turned on. So the current in this particular inductor would be increasing linearly. Okay, and this inductor would be start to store the energy during this on mode. Okay, and the output voltage across the capacitor decreases because diode is in the reverse bias condition, so it would be remains whatever the charge already stored on the capacitor, that would be start to discharging. Okay, and in this way capacitor C1 would be actually supplying a current to the load. This current would be not flowing because diode D1 is off condition. The whatever the charge stored at initial condition to the capacitor, that would be start to discharging, and this current would be start to flow across the load. So I think that was the doubt on your mind. Now come to the second condition. What happens? This is the voltage equation that I have to just mention here, and this is the current equation across the inductor. So initially the current is 0 and is a 0 steady state condition. Then at the time domain, your current would be start to increase. That would be Vi minus V sat upon L1 T. So I would become later on. Now come to the second condition. What happens when Q1 is off? When Q1 is off, at that moment, VL would be reverses its polarity. VL would be reverses its polarity. Okay, as in the previous discussion, the same reason is there. Now, as the VL would be reverses its polarity, at that moment, the polarity across the D1 would be also reversed. Now, diode would be become forward bias. So when the diode would be become forward bias, there is some voltage would be drop across this diode, that is Vs, and this IL would be now follow this path. It would be not enter to this path because the switch is off. So current would be follow now this path as well as this path. Okay, so it would be flow through this or either through this, depending upon whatever is the less impedance offered by the capacitor or the load. Okay, now at that moment what happens? Current would be start to decrease across the inductor because inductor has already stored the charge. Now it would be start to the polarity has been reversed, so it would be start to decreases the current. Okay, now you can see the voltage across the output terminal would be what? Now in this condition, you can simply apply the KVL. Vi, you can say Vi then plus VL because the polarity is changed. See here, okay, Vi is from negative to positive, it is plus. So similarly, it is again negative to positive, then plus. Then the voltage across diode Vf minus. Then the voltage across output is minus because it is plus to minus. Now, what is the value of V0? V0 would be become Vi plus VL minus Vf. Okay. Start to filling your attendance simultaneously. Now you can see that D1 is what happens? It would be forward bias, and as the diode is forward bias, your capacitor C1 would be recharged from the inductor current. It would be start to charge. Okay, so in this case, your capacitor would be start to charging, but it is charged because of the discharging of the inductor. So VL would be start to decrease. Okay, start to filling of your attendance. I have turned on the And one thing is that IL would be always remains higher than the I naught, and because of that only your output voltage would be keep increasing. And in this case, your output voltage would be larger than the input voltage. That's why its name is boost converter. So you can this is the some voltage and current equations that I have mentioned here. You can see that V naught is Vi plus, here the Vi plus VL, and VF is cut-in voltage across the diode, maybe 0.6, 0.7 volt depend upon silicon. Okay, so it would be always greater than the Vi. So output voltage is always larger than the input, and its actual value would be depending upon the value of R1 and R2 that we have shown in the first circuitry of the boost converter. And this is the current equation across the inductor at that moment. The current at the t on time plus, it would be increasing now, just plus the output, the voltage across the inductor upon L1 T. And the idea would be more clear through this particular waveform. You can see here. This is the VA voltage across the switch. So when the switch is turned on, then what happens? Voltage across switch is only Vset. That's why it is shown as a not negative, it is positive. Remember this, because it is above the ground. Okay, only it is showing as a decreased value because the voltage at that moment only Vset, because switch is connected across the input. Okay, so at that moment the voltage across inductor is Vi minus Vset, that we have already seen, that is positive. And at that moment also your current across the inductor is linearly increases, and because of that whatever output voltage, actually it would be remains as constant, but there will be a little bit variation. You can see as the IL increases, your output voltage little bit decreases from the base level. Okay, and it would be decreased till your IL would be reached to the peak value. Okay, and that is only happen when your Q is on. But when your transistor is off, at that moment your voltage across the switch would be increased linearly. You can see here it would be become Vi plus VL. It would be raised from the value of Vset to the Vi plus VL, and at that moment what happens? It would be the voltage across the inductor would be dropped, that it would be equal to V0 plus Vf. Okay, and at that time the current would be start to decrease